When it comes to finding the equivalent of a circuit, it is important to know if it is passive or active. An active circuit has an independent power source. If it doesn't have an independent power source, then it is a passive circuit. For example, consider the circuit within the dotted blue line. If we want to reduce this circuit within the dotted blue line to an equivalent, the first thing we have to answer is it active or passive? There is no independent source inside the dotted line. Therefore, even though you have a dependent source, this circuit can be reduced to an equivalent resistance. That's because it is a passive circuit. This is easier to see if we remove the external source and focus just on the part that is within the dotted line. As you remember from lesson number 2, to find the equivalent resistance of a circuit, of a passive circuit, we just pass a description of that circuit to a script that is called ER, or equivalent resistance, specifying the two nodes between which we want to find the equivalent. That's what we would do to simplify this circuit. On the other hand, if the circuit is active, meaning if it has an independent source, then we need to find a Norton or Thevenin equivalent. That is to say, an equivalent that has a source and a resistor. We can do this in Symbulator using a script called TH. The TH script finds the Thevenin and Norton equivalents of an active circuit between two terminals. It works by running a simulation of the circuit as it is and finding the voltage between the two nodes, and then running a second simulation with a short circuit between the terminals and finding the short circuit current. The TH script takes three arguments. The first is the description of the circuit as a string, the second is the node of the first terminal, and the third is the node of the second terminal. Now, here the polarity matters because the equivalent is going to be given in terms of the nodes in the sequence you provided them. For example, consider this circuit. We are asked to find the Thevenin equivalent as seen between the terminals connected to this load. So since it has an independent source, we will need to use the TH tool instead of the equivalent resistance tool. You see that we have a dependent source here that depends on the value of Vx. Now the calculator has no idea what Vx is, so we need to define Vx as Va minus Vb. And then we can proceed to describe the circuit. We have an independent source here between A and 0, value Vs. We have a dependent source between 1 and 0 with the value of mu Vx, because we already defined Vx. And then we have a resistor Ro between B and 1 with the value of Ro. We store that description in a variable, and then we invoke the TH script for that circuit between B and 0. So let's see how this is done in the calculator. We define Vx equals Va minus Vb. It has to be the subtraction sign, minus Vb. Now that variable has been defined. So we can go and get our circuit description that we're going to store between the quotation marks. Here we have it in the text editor. We copy it and paste it within the quotation marks, store it in the variable sir, and then we invoke the th script saying I want the equivalent between nodes B and 0. We run it, and then you can see that Symbulator asks for the whether it's a DC or AC or what type of analysis. You specify that. Symbulator runs an open circuit simulation and then runs a short circuit simulation. And now to retrieve the answers, we ask for VTH, a variable that has the Thevenin voltage. We ask for REQ, which has the Thevenin resistance, or it's really the equivalent resistance. And if we want the Norton, so that basically those two variables constitute the Thevenin equivalent, VTH and REQ. And you can see that they match the answers from the book shown on the top of the slide. If we wanted the Norton equivalent, the resistance, the Norton resistance is the same as the Thevenin resistance because it's the equivalent resistance. But you need the Norton current, and that's stored in I and O, as in current in Norton. And that's the right answer right there. Now this scripts TH gives us more answers that we will see in the next lesson. But these three answers, VTH, REQ, and I and O, are the Thevenin and Norton equivalent of any active circuit.